All right, picking up right where we left off in the last video. This is an inverse. Let's go see if we can prove two things are inverses. So graph the line y equals x, f of x equals 3x, and g of x equals 1/3 x on the graph provided. Are f and g inverses? If so, prove it algebraically. All right, so let's do this visually first, graphically first, geometrically first, however you want to say it. We'll just start with some axes here. Sweet. All right, now that line y equals x. Well, in the last video, the line y equals x was green. I will also make it green here, just so we know that that's not a function we're actually talking about. This is the line that we are flipping over. I'm trying to hit all the points pretty good. Okay, cool. So this is the line y equals x, for those of us not working in colors. F of x is 3x. So 3x, remember that's a linear. Y equals 3x. You can start at a y-intercept of 0, and then the slope up 3/1. And it would keep going up 3/1. It would go down 3 back 1, down 3 back 1. You don't have to plot all these points, but we are trying to prove this is an inverse, so maybe we want a few good points. And there's our f of x. Okay, now g of x, let's use orange, is 1/3 x. Again, we see a y-intercept of 0. We go up 1/3, up 1/3, up 1/3, down 1 back 3, down 1 back 3. Now, visually, kind of hard to tell, right? Are these in fact reflections? I mean, it flips over the line. So let's check a couple points. Let's look at this point here. This is the point out 2 and up 6. Hopefully on G there is a 0.62. Let's take a look. Out 6, up 2. There is in fact out 6, up 2. Let's check the other half now. Back 3 and down 1 for G of x. Do we have back 1 and down 3 on f of x? We in fact do. Now, while that's all fine and dandy, that's not necessarily enough to prove that these are actually inverses, okay? We'd have to go through every single point and make sure every single point was in fact opposite. So visually, I think we're pretty comfortable saying these are inverses, but now we need to prove it, and they want us to do it algebraically so we don't have to waste our time going through every single point, because that's really exhausting. So let's go over here now. Let's see if we can prove it algebraically. We think that they are inverses, but let's take a look at f of x here. Well, remember, f is just the name of the function, so why don't we ditch that for a second? Let's just go back to y. Okay. Now, what does it take to be an inverse? Well, on the points here, all the x's became y's and y's became x's, right? They inverted, hence the name inverse. So what if we invert the actual equation? Let's change the x's to y's and the y's to x's. Sorry, I want to fix my equal sign there. If we change every x to y and every y to x, do we get something that looks like g of x? Well, not really, right? This doesn't look like g of x, but maybe let's solve it for y, divide by 3 on both sides, which is kind of tricky because then on the other side you end up with x over 3. But remember, that's the same thing as 1/3 times x. You can always welcome to take that that x out. Oh, and hey, look at that. 1/3 x was g of x. And so we have proved that they are in fact inverses. Now you might want to draw a dotted line here, because when you invert a function, you're no longer talking about the same function. So we don't want to say that f of x equals g of x, because it doesn't, right? If you switch those places, they're not the same. But we can say that definitely f of x and g of x are inverses. All right. Now that's super nice, but what if we didn't want to have to come up with a bunch of names? What if we were looking at a whole bunch of different functions and trying to find their inverses? Well, inverses have a strong connection, right, as opposed to just some random other g function. And so we can come up with a certain notation. In the next problem, we're going to use something like this, and from here on out, we're going to use that notation. So if we're back in our problem right here, f of x and g of x being inverses means that g of x could be written as what we call f inverse of x, meaning this is the f function has been inverted. So it's not a super big change. All you do is throw that -1 on there. If you remember back to trig, it's like sine and sine inverse, right? Or cosine and cosine inverse. Now it's function and function inverse. Okay, so it's just your opposite function. It's just a special notation, just like f of x is a special notation, right? We just got a new one. It's just usually we use that so we don't have to come up with a whole bunch of different letters. All right, let's keep going. Yes. No, let's go into the next function or the next video and we will do the next 4 problems all the same.